Okay, hold on. Let me... Give me a second, guys. I'm gonna, let's see here. So this is gonna be kind of a, oops, let me actually, hold on. Okay. So this is gonna be a, let me, there we go. Okay, so in this live stream, what I am gonna do is I am just gonna go over algebra in a very brief way, but I'm gonna do a lot of practice problems in this live stream. So I don't know how, oh my goodness, I'm trying to connect this. I don't know how clear or how fast this live stream will be, but I also don't want to go over like literally one example per how do I say it? Like one example per section. I only say that because, I mean, it's just, I don't think that, I don't want to go too fast either. I don't think that that I'll do everything in this live stream. So I'm just kind of naming it, and then by the end of the live stream, I will probably change the title of it. I don't know. I'm gonna try to do as much as I can about algebra and all that stuff. So let's start with 1.1, and I'm not even gonna go over the. I'm not gonna really go over the whole, like, how do I say it? The whole like example problems and just the definitions and everything. I'm just gonna go all the way down, and I'm gonna go to the practice problems. Let's see, hold on. So, and I'm not saying that I'll do every problem. It really depends, because of course I'm not perfect. Nobody's perfect. So I will do like everything that I know from college algebra, okay? So let's see. So number 2 rather. What is the order of operations? What acronym? So let me go ahead and just grab this and put it here. And give me a second, guys. I'm gonna put the chat so that way if anybody says anything, I can actually see what they're saying. Even though I really don't know who's gonna talk on chat, but I will put it anyways, just in case. So, let's see. Live chat. Okay, there we go. And just grab this. So, let me go back to where I was. So what is the order of operations? Okay, that's the first question. So the order of operations, I'm going to just explain this very quickly. You can do, so the order of operations is either GEMDAS. There's two kinds. I mean, honestly, so it stands for grouping. So this is order of operations. It stands for grouping, exponents, exponent, multiplication, division, addition, and subtraction. Okay. And I hope that it's showing up. Hold on. I hope that what I'm doing on the... Okay, good. It is. So that is what the order of operations stands for. Now, if you are like more old school, like if you remember back then, they used to call it PEMDAS, which was parentheses, exponents, multiplication, division, addition, subtraction. Okay, so that's what PEMDAS is. That's what we use to do order of operations, like these problems here. what do the associative properties allow us to do when following the order of operations? So associative property, okay, so associative property, I think it's the following. So that means if we have A times B times C, this is equal to A times B times C. Or if we have A plus B plus C, this is equal to A plus B plus C. I think that's what associative property is. I think. If I'm wrong, please correct me. Because I'm not 100% sure. Let me see very quick just to make sure. Excuse me. Hold on. I'm looking. So yeah, that's what associative property is. Okay, perfect. Okay. Let me go back. So for the following exercises, simplify the given expression. We have this, and hopefully I can get these right. And I will check with a calculator just to make sure. I mean, I'm sure it is not hard. This is just order of operations, really. It's literally what you first learn. I feel like you learn it in pre-algebra, and also like basic math. This is very basic math. It's arithmetic. So we have 10 plus 2, and then we have times the quantity 5 minus 3. So the way that you would do it is you go from left to right. Now, parentheses is always first, so we have 10 plus 2, and then times, and then whatever's inside the parentheses we solve first, so it's times 2. Now we have 10, and then it's going to be plus 2 times 2, so multiplication I believe is next, so it's going to be 10 plus, and then 2, and then it's going to be plus 4, I think, so I think this is 14. It's been a while. Okay, let's see, hold on. Yes, 14, okay. Number 5, it says 6 divided by 2, so okay, hold on, guys. I don't know why it's... Okay. The second one says 6 divided by 2. And let me actually... Hold on. Give me 1 second, guys. I'm gonna look at... Just to make sure the... Give me 1 second. I just want to make sure that it's running smoothly, because honestly, like, okay. So okay, so number 4 is 14, right? We're going to go to number 5. It says 6 divided by 2, so minus the quantity 81 divided by 3 squared. Now, again, you always do what is inside the parentheses first. Now, you can do this part. 6 divided by 2, that's going to be 3. And then minus. And then 81, so then 3 squared is 9. It's going to be 81 divided by 9. So then you have 3 minus, and you're going to do 81 divided by 9 is 9. So then you have 3 minus 9, that's negative 6. Okay. Very easy. And let me just go ahead and do this very quickly. Okay, yeah. Okay, so number 6 says 18 plus 6 minus 8 cubed. So 15 plus the quantity 6 minus 8 cubed. This is going to be 15, and then you have plus, and then you have 6 minus 8, that is negative 2. And then cubed, that's 15 minus 8. So that's going to be 7. How do I know that 6 minus 8 is negative 2? So that is 6 plus negative 8, right? And you, in reality, the way that I like to do this is I like to say that negative 8 plus 6, if you don't know how to add negatives with positives, negative 8 plus 6 is really negative the quantity 8 minus 6. So then it's negative 2. Okay? That's the way you can look at it. You can use factoring, okay? Or you can do like a table where you do like, I know in middle school they taught me this. You do positives and negatives. So you have negative, so you have like 8 negatives, right? So basically you have something like this. Hold on. One, 2, 3, 4, 5, 6, 7, 8. Oh my god, guys, I'm sorry. I don't know why my... Okay. And then you have 6 positives, so you have 1, 2, 3, 4, 5, 6. And maybe we can do this like, so now you're going to cross out 1 positive for every negative, right? So you're going to have 1, 1, 2, 2, 3, 3, 4, 4, and this is another one, so 5, 5, and 6, 6. So how many negatives are left? 2 negatives, right? So it's going to be negative 2. Right? That's how they taught me when I was in I want to say 6th grade, or like even like 7th grade, stuff like that. So okay. Okay, so that's how you do that one. let's do number 7. So number 7 says, okay, hold on. 2, so it says 2 times 16 divided by it's -2, my bad. -2 divided by, or times 16 divided by 8 minus 4 squared. Oops. Okay, so this one's a little harder. What you're going to do, you're going to go on the very inside of the parentheses, so you have, just kind of do this, right? And you're going to look at the very inside parentheses first, this part. What is that? So it's going to be 16 divided by, and it's going to be 2 squared, right? And then squared, right? So basically you have that, and then you're going to do -2. You're not going to multiply it yet. -2 times, and you're going to do 16 divided by, and what is 2 squared? That is 4 squared, right? Now, before you multiply anything, so basically you do this, so basically you have -2, and you have, remember GEMDOS? Or PEMDOS if you use PEMDOS. I'm going to write it like this. So PEMDOS is parentheses and then exponent. So what is inside of the parentheses? That is going to be 16 divided by 4. So we're going to go ahead and do that. So we have -2 times the quantity 4 squared. That is really -2 times 4 squared. So what is 4 squared? 4 squared is 4 times 4. And what is 4 times 4? That's 16. So we have -2 times 16. -32. Okay? And that's how you do that one. So that's very simple. That's like very simple arithmetic. Now we're going to go on to algebraic. So we have 8 times the quantity x plus 3 equals 64. Right? And so, okay. This one, what you're going to do, you're going to do distributive property. So anytime, remember, distributive property says okay, so distributive property says 8. So it, okay, if we have the following, so A times a quantity, B plus or minus C, this will be A, B, oops, my bad. It's going to be A, B, plus or minus A, C, okay? So that means we have 8 times x plus 8 times 3 equals 64. So that will give us 8x plus 24 equals 64. Now go ahead to solve for x. Number 1, subtract 24 on both sides, okay? So we do that, right? Minus 24 on both sides. So we have 8x equals 40. And number 2, divide both sides by 8. So now 40 divided by 8, if you don't know what that is, you know that, so basically you can do the following. You can do division where you do 40 and you can divide it by something that is more easier. So if you do this, 2 times 2, that's 4, subtract it, and then 0 divided by 2 is just 0. So you have 2 times 20 over, and then 8 can be simplified as 2 times 4. So that gives you 20 over 4. And then 20 over 4, if you reduce it. So you can say this is equal to 2 times 10 over 2 times 2. This is 10 over 2. Reduce it again. This is 2 times 5 over 2. So your answer becomes 5. X equals 5. Okay. That is if you don't know like how to divide, or if you don't remember like how to divide numbers, but yeah. Let's see, let's do number 29. 4y plus 8 equals 2y. So 4y plus 8 equals 2y. So if we do this one, number 1, subtract 4y on both sides. So that means we have minus 4y on both sides. So basically we have, this cancels out, we have 8 is equal to, and 2 minus 4y, that's negative 2y. If we divide both sides by negative 2, we get that y is equal to negative 4. Okay. 11a plus 3 minus 18a equals negative 4. (11a plus 3 minus 18a equals negative 4. Now, this one, you're going to go ahead and say 11a minus 18a plus 3 equals negative 4. That is the associative property, okay? So you have negative, so 11 minus 18, that's negative 7. A plus 3 equals negative 4. Subtract both sides by 3, so minus 3 on both sides. you have negative 7a equals negative 7. Divide both sides by negative 7. You get a equals 1. Okay? That's how you do that one. Oh my, it's raining outside. Or thundering. Okay. Interesting. So, let's do number 34. 8 times 2 plus 4. So 8 times 2 plus 4 minus 15b. So let me actually write this down in hold on, guys. I'm gonna try to like make it look so that it's, I'm not sure why I can't. Hold on. Let me kind of extend it a little bit. Okay. So this one, we can do either distributive property for this part. So, or we can do, this is 8, and then this part here is 6, so 8 times 6 minus 15b equals b. So what is 8 times 6? That is 48 minus 15b equals b. So then what happens next? Well, what you're going to do, you have two choices. Number one, you can subtract b on both sides. You have 48 minus 16b equals 0. And then you can go ahead and add 16b on both sides. And you have 48 equals 16b. You can divide both sides by 16, and this gives you 6 times 8 over 8 times 2. These two cancel out, is equal to b, so 6 over 2 equals b. 3 times 2 over 2 is equal to b, so b is equal to 3. Okay? If you don't know, if you don't usually like to do like division where you have to like do it by a really big number, I really recommend that you kind of divide it on the side. So for example, if I don't like doing 48 divided by 16 by myself, I would usually say, well, what is 48 divided by 2? That is 24. Okay, so we have 2 times 24 over 16. And what is 16? Well, that's just, so it's going to be 2 times 24 over 2 times 16. These cancel out. So then I say, okay, what is 24 over 16? That is really just 6 times 4 over 4 times 4. These two cancel out. So then what is 6 over 4? That is just 3 times 2 over 2 times 2. So that's 3 over 2. Right. Did I do that correctly? Six times 4 over 4 times 4. Oh, wait a minute. My bad. Sorry, guys. I meant to say 2 times 8. So then that's 6 times 4 over 4 times 2. These two cancel out. I get 6 over 2. So then that's 2 times 3 over 2, which is just 3. Right? Which is what I got over here. Okay. That's how you do it if you don't want to divide by, like, if you don't like doing really big numbers when you divide. Let's see. Let's simplify linear expressions. Let's do number 51. Number 51 says the following. 9x. Let me actually, hold on. Let me do it this way. I'm just going to go ahead and write it down. 9x. So let me grab, hold on. Put this up here, and then I'm just going to go ahead and from my monitor, if I can just, so number 51, oops. Sorry about that, everyone. Okay, so number 51. We have 9x plus 4x times 2 plus 3 minus 4 equals, oh, my bad, no, minus 4 times 2x plus 3x. Okay. And I'm going over this very slowly because I know that in my other videos when I used to do stuff like this, especially when it came to calculus, and by the way, if you hear rain, guys, it is raining outside. It is pouring like crazy. So, let me... Okay, yeah. So, yes, I'm going over this for those of you who need an in-depth review of college algebra. And I'm doing it, but I'm trying to do it like maybe a few problems per section. Not every problem per section. So let me, hold on, guys. There we go. Okay, so let's look at this one. We have 9x plus 4x times the quantity 2 plus 3 minus 4 times the quantity 2x plus 3x. Now, what do we do first? So we have 9x plus, and then 4x, and what is 2 plus 3? That is just 5, right? So if we kind of grab, kind of color code here, this is a 5 minus, and then we have 4 times, and what is 2x plus 3x? That's going to be, oops, 5x. Okay. So then we have 9x plus 20x minus 20x. So then this is just 0. So we have 9x plus 0, which is just 9x. Okay. Let's look at the next one. So let me... Ooh, let's look at number 49. So we have the following equation. hold on, number 49, and let me try to so let me try to do it this way. Hold on. Number 49 says, let me try to do it in ink math. Maybe I can do it in ink math. Hold on. So we have 4/9 squared times okay, I don't know why it doesn't do a never mind. I don't know why it doesn't do this, but I guess it doesn't want to. Basically, I'll just show you guys on the screen. Hold on. So this one, 4/9 squared times 27x, okay? So, I'm gonna just write them down. So what is 4/9 squared? Well, if you do a over b quantity squared, you know that this is a squared over b squared. This is a property, okay? It's a power of a division of two numbers, or a power of a fraction, really. So we have 16. So really we have 4 squared over 9 squared times 27x. So that is going to be 16 over 81 times 27x. Now we can write this as the following. We have 16 over, and then we can say 81, and then times, and then we can say 27x, right? Now, we can break up 16. 16 can be the following: 2 times 4, or actually we can say, well, we can say 2 times 4 squared, right? Because we know that 4 times 4 is 16, so 4 squared is 16, right? And then we can say over, and then we can do 81 as 9 times 9. And then we can do 27 as 3 times 9, and then times x. So bringing this all together, we have 2 times 4 squared over 9 times 9 times, so we have, let's keep it as one fraction, so we have times the quantity, and let's put this in parentheses, 3 times 9 times x. So it cancels out. We have 2 times 4 squared times 3 times 9 over 9 times 9 and then we have times x, right? So we know that 9 cancels out. We know that, let's see what else. We know that 9 is also, so if we kind of grab this 9 here, right? So, like that. And if we say 2 times 4 squared times 3x, this can be, or rather 3 times x, this can be over 3 times 3. Oh, wrong color. So basically these two 3's cancel out, and we are left with 2 times 16 times x over 3, which is really 32x over 3. Okay, and that is how you do it. That's what this equals to, 32x over 3, right? Let's look at number, so let's see here. So let's move on to the next section. We're going to move on to the next section. So we can also use, so we can simplify exponents using the product rule, and I'm going to go over a few of my own. There's many examples, but this part has to do, so basically I'm going to just go ahead and write the, I'm going to write down the, and actually, hold on, let me look in here very quickly. Hold on. Let me just, okay, hold on guys, I'm sorry. It keeps, I don't know why it's reacting, or it's like, wanting to crash for some reason. Let me put this, okay. Okay, so, okay, so exponents in scientific notation, so that is 1.2. So, what is an exponent? Well, an exponent, and this is going to be from my own knowledge, is, so, okay, it's a number that you multiply. Okay, so it's the amount of times you multiply a number by. And Give me 1 second, guys. I'm gonna go ahead and just put for my I'm trying to see how I can. So instead of actually putting it so that it mutes, or like, what is it called? Like instead of, so let me see. Enable push to mute. Hold on. Trying to see how to do it so that it does push to mute very quick. Instead, so that way, if I'm typing something, it doesn't mute it. Hold on, guys. Video. Push to mute. Here it is. Okay. Or actually, not desktop audio. No. Mic. Okay, I think it works. Sorry, guys. I know that took a while. Ugh, my bad. I just wanted to make sure that it was actually okay. Sorry, I was trying to see how I can do push to mute instead of having to. Okay, I think it works. Oops, my bad. Anyways, my bad. So anyways, I was trying to do push to mute just so that instead of when I'm typing, it doesn't actually mute it. Because I may just type a few things here, but yeah. Okay, so let's see. So what do I mean by that? If we say 2 cubed, okay, if we say 2 cubed, for example, this is 2 times 2 times 2. If we say 4 cubed, this is 4 times 4 times 4. If we say 1 cubed, this is 1 times 1 times 1. If we say 2 to the 5th, this is 2 times 2 times 2 times 2 times 2, and so on and so forth. So any little number that you put up here, that is what your exponent is. So let me label this. So let me color code this. Hold on. This is your base, and this is your exponent. Now, that is what an exponent is. So here, when we, for example, let's just do this with numbers, right? Let's say that we have something like 2 to the 14th times 2 to the 15th, and we want to know what that equals. Obviously, we can't do, I mean, you can, but it'll take a really long time. So let's say multiply and so what do I mean by exponential form? That means a to the n, like this. It has to be a number to a certain power. So what is this going to be? Well, if you know laws of exponents, this is, so there's one called the product rule, or the oh my, what is it called? What is it called, really? Is it product? Oh yeah, product rule of exponents. Yes, there it is. I didn't see it earlier. That is a, so, okay, hold on. A to the m times, oops, okay, hold on, times a to the n is equal to a to the m plus n. Okay. Now, this means that this will be, so we have, this is going to be 2 to the 14th plus 15. So what is 14 plus 15? That's just going to be 2 raised to the 29th power. And this would be your answer because it wants it in exponential form. Remember, exponential form is of the form a to the n, where n is greater than 0. Okay? And why do I say that? Because remember that anything to the 0 power is 1. If I say 2 to the 0 power, that's 1. Negative 3 to the 0 power, that's 1. Negative 1/2 raised to the 0 power, that's 1. If I say xyz cubed over 3 squared raised to the 0 power, that's 1. Doesn't matter. Anything to the 0 power is 1. So it has to be greater than n, or it has to be greater than 0 for it to be of this form. If it's less than 0, if we have a to the negative n, this is going to be 1 over a to the nth. You just move it to the denominator. Okay? So that is a product rule of exponents. Now, let's go ahead. Oh, and this is the difference rule, right? The difference rule is, instead of, so if we have a to the m over a to the n, this is equal to a to the m minus n. Okay, so that means if I have 2 to the 27th over 2 to the 20th, that's just going to be 2 to the 27 minus 20, which is 2 to the 7th power. And again, I would leave it in exponential form. Right? Now the power rule of exponents says if we have a, so let me do it this way. A raised to the x raised to the y power. This is called the power rule of exponents. So this would be equal to a raised to the x y power. So let's say I have 2 cubed raised to the 2nd power. What is that going to be? That is going to be 2 to the 3 times 2 power, which is 2 to the 6th power. And let's just say it wants it in a to the m power, where a, so I'm going to try to explain this as best I can. So I'm going to say a to the b power, where a to the xy is equal to a to the b, and xy equals b. I will explain this so basically, okay, so the way I can explain this is whenever you have the same base, if I have 2 to the x equals 2 to the 3x minus 1, they're the same base. So x equals 3x minus 1. That is the property of equality, or I forgot what the rule was called, but if they have the same power, the same exponent, then you have to do the equality property. That's why here 2, so basically 2 raised to the 3 times 2 is really, or 2 cubed raised to the 2nd power is 2 cubed, 2 to the 3 times 2 power, and they have the same base. That is why a would be a and xy would be xy, right? I'm trying my very best to explain this stuff. If anybody has any questions, let me know. Hold on. Okay. Now, anytime you have a negative exponent, so let's say we have x to the negative 3 times x to the negative 2. So you can say x to the negative 3 is really just 1 over x cubed. Anytime you have x to the negative n, that's just, and let me color code this, x to the negative n is equal to 1 over x to the n. So this would be, this will be 1 over x cubed times 1 over x squared. So this will be 1 over x cubed times x squared. And remember, you add the powers, so it's going to be 1 over x to the 5th. Okay. So let's do parts A through D. Okay, even though, I mean, I know that the answers were just there. So we have t to the 7th. So t to the 7th over t to the 7th. That's easy because they both have the same anytime. So basically, anytime you have n over m and n equals m, then n over m equals 1. So here we have, they're both the same, so this is just going to be 1. This one's interesting, dE squared, so dE squared to the 11th power over 2 times dE squared to the 11th power, so hold on, guys. So think of this as one term, and then look at the bottom as well, right? You see that they're both being multiplied, and they're the exact same thing. So what are you going to do? Just cancel them out. This is just going to be 1 over 2, not 2, 1 over 2, because anytime, so you have 1 times dE squared to the 11th over 2 times dE squared to the 11th. These two cancel out, so you're left with 1/2. Okay. Oh, and then part C is w to the 4th times w squared, so w to the 4th times w squared over w to the 6th. Now this is really just w, and you're going to add the little numbers here, 4 plus 2 over w to the 6. This is w to the 6 over w to the 6, and remember, if they're the exact same thing on top and bottom, then that's just going to be 1. Okay. That's like dividing numbers. If I say 2 over 2, that's 1. If I say 3 over 3, that's 1. If I say 36 over 36, that's 1. It's the same with algebra. Okay. If the top looks exactly the same as the bottom, then it'll be 1. Okay, so t cubed times t to the 4th, so t cubed times t to the 4th over t squared times t to the 5th. So t cubed times t to the 4th, that's t to the 3 plus 4 power over t, and then it's t squared times t to the 5th, that's t to the 2 plus 5 power. So that's going to be t to the 7th over t to the 7th. And again, they're the exact same thing. So you're just going to cross it out. And this is what I forgot to do here. I forgot to cross it out. This is just going to be 1. Okay. Hold on, guys. Now, what about the negative rule of exponents? Well, okay, so for example 5, let's just look at example 5, or example, well, parts A, B, and C for example 5. Let's see, hold on. So we have, and if anyone, like, if you don't know what this symbol means, it's okay. It's theta. That's the symbol. So we have A theta cubed over theta to the 10th. Now there is a way you can do this. You can say this is theta to the 3 minus 10, which is theta to the negative 7. And remember, I said that a to the negative n is really just 1 over a to the n. So this would just be 1 over theta to the 7th. Now you can do it that way, or you can do it this way. Theta cubed over, and you can say theta cubed times theta to the 7th. So then you have, this is theta cubed over theta cubed times theta to the 7th. These two cancel out, you get 1 over theta to the 7th power. Okay, so this one we have z squared times z over z to the 4th. So part B, that's really just z squared times z. So we can do it this way. We can say z to the 2 plus 1 power over z to the 4th. This is z cubed over z to the 4th. Now this can be, the bottom can be split up as, so we can say z cubed over z cubed times z. These two cancel out, we get 1 over z. Okay. This part C is a little more trickier. Negative 5t cubed all to the 4th. So negative 5t cubed all to the 4th over negative 5t cubed all to the 8th power. Okay. Now we can do the following. I mean, we can say that u is equal to negative 5t cubed. So we can say this is u to the 4th over u to the 8th. This is really u to the negative 4, which is really just 1 over u to the 4th. And we substitute u back in, so we have 1 over negative 5t cubed raised to the 4th power. This is really negative, or not negative, 1 over negative 5 raised to the 4th power times t to the 3 times 4 power. And negative 5 to the 4th power, that is, so let's see, hold on. Times negative 5 times negative 5, that's 25 times 5, that's 125, and then times 5, that's 625. So then we have 1 over 625t to the 12th power. Okay. I mean, they did it this way. You can also do it that way. So let's see. Let's actually this time, let's just go to the practice problems. Hold on. Let's look at number 40. ma to the 6 squared, so ma to the 6 squared over times 1 over m cubed a squared. So then we have, so if we do ma to the 6 times ma to the 6, that'll give us m squared a to the 12, and then over m cubed a squared, really. So really it's going to be m times m, and we have times a squared times a to the 10th, because so a squared times a to the 10th is really a to the 2 plus 10 over m, and it's going to be m squared times m times a squared. So really this is going to be m squared times a squared times a to the 10th over m squared times m times a squared, really. So we have this, and then we also have this and this. So what happens to those? They cancel out, right? So we are left with a to the 10th over m. Okay. So let's see, let's look at another one. X to the negative 3 over y. So let's look at number 28. X to the negative 3 over y squared to the negative 5. So this is really x to the negative 3 to the negative 5 over y squared to the negative 5, right? So this ends up being x to the negative 3 times negative 5 over y to the negative 10. Now this ends up being x to the 15th over y to the negative 10. You can do this as x to the 15th over, and then you can simplify this one as 1 over y to the 10th. This ends up being x to the 15th divided by 1 over y to the 10th. So then this ends up being x to the 15th times y to the 10th over 1. So this ends up being x to the 15th, y to the 10th. Okay. All right. I may not do scientific notation only because, yeah, I mean, it just wouldn't, I mean, I don't think that's something that's really briefly mentioned, but, I mean, basically scientific notation is this. I'm just gonna do like maybe 2 problems. So like scientific notation is like, if I say this into scientific notation, this is just gonna be 2 times 10 to the negative 1 power. If I say, if for example they give me something like this, this is really like saying, so it's really like saying, let's see, hold on guys. It's really like saying 3.0 over 2, but you're gonna move your, so let's pretend I have 3.00000, like something like that. Or not 3.000, but like, let's just say I have 3.0. So I'm going to do 1, 2, 3, 4, 5. 0.00003. Or let's just say I have 3, right? 3. It's just going to be 1, 2, 3, 4, 5. So in every little curve here, I'm just going to put a 0. And then over 0 point, and it's going to be, how many? 1, 2, 3, 4, 5. Okay, yeah. It's going to be 0 point, so it's going to be 5 zeros basically. Like not after the decimal point, but like in total, 5 zeros, 0 point. And actually, it's going to be 6 in this one. So 0, 0, 0, 0, 0, 2. It's something like this, right? I mean, I have not done scientific notation in like a really long time. But yeah. Let's move on. Radicals and rational exponents. Okay. Okay, so we're gonna do let's do the square root of 50x cubed y squared z. So that means we're going to have the square root of 50 times the square root of x cubed times the square root of y squared times the square root of z. So what is the square root of 50? That is going to be the square root of, so 2 numbers, so basically you can do it this way, 2 times 25, and then you have times the square root of x squared times the square root of x, times, and then the square root of y squared, that's just y. So the way that square roots work is if I say the square root of, so they're kind of the opposite of taking the power. So for example, if I say 2 squared equals 4, then that means the square root of 4 is equal to 2. So basically, a to the n equals y if and only if actually, hold on. A to the n equals r. Actually, I'm trying to come up with a good property for this. A to the x equals n if the nth root, hold on, actually, I'm going to say a to the n equals x if the nth root of a, or the nth root of x, equals a. So if I say the square root, so if I say, it's like I said, if I say 2 squared equals 4, then that means the square root of 4 equals 2. So if I say 2, let's say I said 2 cubed, and that means that 2 cubed equals 8, so that means that the cubed root of 8 equals 2, right? So, I mean, I don't know if there's a proper definition for a square root. I mean, I do believe there is, but, or a radical. They also call them radicals in this section. They call them radicals. That's another name for it. So it says if a and b are non-negative, the square root of the product ab is equal to the product of the square roots of a and b, right? So anytime you have, that's why I started multiplying these square roots. So basically we have the square root of 2 times the square root of 25 times the square root of x squared times the square root of x, and then times the square root of y squared times the square root of z. So we have the square root of 2, the square root of 25, that's just 5, the square root of x squared. So one of the things that we should know is the square root of a squared is equal to a. So this should be x, and then square root x, and then y, the square root of y squared is just y, and then we have times the square root of z. So then we have 5 x y, because all of them without the square root, 5xy times the square root of 2xz. At least I think that's what it is. Oh, it doesn't give me the answer, but that's what it would be. Now, that goes the same for, so, like, for example, let's say I wanted to do the square root of, like, I don't know. I'm trying to see what, like, which ones, are good examples. So let me, hold on. Okay. Let me look at the previous example. Hold on. Let me see. Okay. Give me 1 second, guys. I'm gonna try to check this on Mathway really quick, or on Symbolab. So, just so I'm sure, the square root of 5xy, or not 5xy, my bad, 50x cubed, so 50x cubed y squared z So yeah, it is 5xy times the square root of 2xz. That's what it is. So for example, we also have the property of dividing square roots. So if we have the square root of a over the square root of b, that's going to be equal to the same thing as the square root of ab. Or a over b, excuse me. The square root of a over b. So, for example, if we have the square root of 2 over the square root of 3, that's just going to be the square root of 2/3. So, for example, let's say they wanted you to simplify the square root of 1/2. And you know that this is equal to the square root of 1 over the square root of 2. But you want to make it so that there's only one square root on the numerator. So you would say times the square root of 2 over the square root of 2. So this would be the square root of 2 times 1 over 2, which is really just square root of 2 over 2. If I have the square root of 5/2, that's just going to be equal to the square root of 5 over the square root of 2, which is really just square root of 10 over 2, right? I multiply by the conjugate, right? That's the next part, which I think they're going to say in a little bit. Hold on. Okay, well, yeah, rationalizing the denominator. This is what I mean right here. So you can't. So basically, in algebra, they don't recommend that you have a square root in the denominator. Remember that if we have a fraction a over b, that means that b is the denominator. Okay. So this will be times, so you're going to multiply it by the conjugate, times the square root of 3 on top and bottom, you get 2 square root 3. And then any time you multiply a square root by a square root and it's the exact same thing, it's just going to be the number itself over 3. So that's basically saying if I have square root of a times square root of a, that's just going to be a. Or square root of n times square root of n, that's just going to be n, right? Oh, my bad. It wasn't, well, I don't know if I actually wrote that one down, but 2 square root 3 over 3 square root 10. So this one, you're going to do times square root 10 over square root 10, which is really just 2 square root 30 over 30. Wait, is it 30? Hold on. So it's going to be 3 times square root of 10 squared. So that's going to be 2 square root 30 over 2 times 10. So this is going to be the square root of 30 over 10. Or wait a minute. My bad, 3 times 10. Oh my goodness. So 3 times 10, which is 30, is really just 2 times 15. So you can simplify it, and then you can say that this is equal to just square root of 30 over 15. Okay. Now this one is interesting. 4 over 1 plus square root 5. Anytime you have a over b plus or minus square root c, this is going to be equal to a times, so basically if you have a over b plus square root c, this will be a over, so it's going to be a times b minus square root c, and then over b plus square root c times the b minus square root c. Okay, so you're, in reality, depending on what your square root is, if it's positive or negative, depending, you're going to do the opposite. So like, for example, if I have 2 over 2 minus square root 3, and I want to rationalize it, I'm going to do times 2 plus square root 3 over 2 plus square root 3 on top and bottom. So then this would be 2 times 2 plus square root 3 over, and I'm going to do 2 minus square root 3 times 2 plus square root 3. And if you don't know what FOIL method is a plus b times a, or the sum of two squares pattern, or the sum and difference pattern, excuse me. This is going to be just a squared minus b squared, because we have a, so it's a times a plus a times b minus a times b minus b times b. So it's a squared, ab minus b squared, right? So this will be 4 plus 4 square root 3 over 2 squared minus square root 3 squared. So this is 4 plus 4 square root 3 over 4 minus 3, which is really just 4 plus 4 square root 3 over 1, which is 4 plus 4 square root 3. Okay. So you see how they do it here? What they do is they do distributive property, and then on the bottom part they do distributive property again, but that's my point, is that anytime you have, so if you have a plus b times c plus d, or actually, hold on, it'll be so I'm trying to think about how to say this. Right. I think that's how you say it. So like, I mean, there's 4 different kinds, but we can go over it later on. But that's how you simplify the square root. And these are just radical rules. So like, for example, if I have a to the m over n power, this is really just the nth root of a raised to the m. So this can be equal to, and so if I have a to the 2/3, this is really just the cubed root of a squared. A to the 1/3, this is just the cubed root of a to the 1st, which is equal to the cubed root of a. Now let's say I have a to the negative 1/5. That means I'm going to have the 5th root of a to the negative 1, which is the fifth root of 1 over a, which is really just 1 over the fifth root of a. And if I do times the fifth root of a on top and bottom, this is just going to be the fifth root of a over a, right? So let's do part A, like for this one. So it's 5 times 2x to the 3/4 power, right? Times 3x to the 1/5 power. This is really just 5 times 2 times 3 times x to the 3/4 plus 1/5. Now, if you do not know how to add fractions, really you just have to say a over b plus c over d equals a times d plus b times c over b times d. This will be 3 times 5 plus 1 times 4 over 4 times 5. This is 15 plus 4 over 20, which is 19 over 20. So it's going to be 30, so it's going to be 10 times 3 times x to the 19 over 20. So 30x to the 19 over 20. So you see right here, 16 over 9 to the negative 1/2. So 16 over 9 to the negative 1/2 power. That'll just be, so in reality, I would write this as the square root, so of 16 to the negative 1, right, over the square root of 9 to the negative 1. So what is this? This is the square root. So let me actually do it this way. Hold on. So this is going to be 16 to the negative 1/2 over 9 to the negative 1/2. So this is going to be the square root of 16 to the negative 1. Because square root, it's like 2 right here. So it's square root. And then over the square root of 9 to the negative 1. So this is going to be, it's going to be the square root of 1 over 16 to the first power over the square root of 1 over 9. This is really just the square root of 1 over the square root of 16 over the square root of 1 over the square root of 9. So this is going to be 1 over 4 over, and then the square root of 1 is 1 over, and then the square root of 9 is just 3. So 1/4 divided by 1/3, that's just 1/4 times 3 over 1, which is 3 over 4. Keep it, change it, flip it. That's what it is. So that's 3/4. So you see, let's move on. For the following polynomials, identify the degree, the leading coefficient, and the leading term and the leading coefficient. So anytime you have a polynomial, for example, let's look at the first one. 3 plus 2x squared minus 4x cubed. The power of this polynomial, or the degree of the polynomial, so anytime you have a polynomial ax to the n, this is the degree, this is the leading coefficient, and this is the term. Or actually, hold on. Actually, the term is the whole thing. So the term is really, so this whole thing is the term. That makes sense, right? So here in this polynomial, we have, if we write it from biggest to smallest, from the biggest degree to the smallest degree, it's negative 4x cubed plus 2x squared plus 3. So what is the leading coefficient? It's always the first number that appears with the highest degree power. So the number right here that is the highest, that is the leading coefficient. Like, basically what I'm trying to say is that if we have 4x cubed, negative 4x cubed, this is the highest power. So the leading term is negative 4. And then leading coefficient, hold on. So the leading term, and so that's a leading coefficient. The leading term is negative 4x cubed, and the highest power, so the degree, so the degree of the polynomial is 3. So for example, let's say we have negative 2x cubed plus 4x squared plus 9x minus 1. What is the leading coefficient? The leading coefficient is the one with the very front number with the biggest degree. So it's going to be negative 2. That's going to be the leading coefficient. And then and then negative 2x cubed, that's going to be the leading term. And then the degree is going to be 3. Let's say we have like this, right? Or let's say like that. So again, we want to write it in terms of descending exponents. What does that mean? That means that the little numbers here are going to be decreasing. So we have a negative 3x to the 5th. That's one part. We also have a 4x cubed, and then we also have, hold on, a 9x, And then we also have a -3. So what is the leading term? The leading term is going to be, so we want to go from highest to lowest. So degrees, oops, my bad. So the degrees from highest to lowest are going to be 5, 3, 1, and 0. Because remember, 3x to the 0, that's just, or -3x to the 0, that's just -3. So we're going to have -3x to the 5th plus 4x cubed plus 9x minus 3. So then this is going to be, so the leading coefficient is -3. The leading term is -3x to the 5th, and the degree is 5. Okay, that is all that is saying. Okay, adding polynomials. So adding polynomials, let's see. 12x squared plus 9x minus 20. So let's look at this one. Let's just look at it. Or let's look at, well, yeah, let's look at this top one. 12x squared plus 9x minus 21. So plus 4x cubed plus 8x squared minus 5x plus 20. Okay. And looking at this, okay, hold on. So we can go ahead and take the parentheses off. It is okay to take the parentheses off, and this is something that we really have to pay attention to. It is okay to take the parentheses off if there is no negative in between those parentheses. So I can take the parentheses off of this one because it's not really going to change anything. Now, the next thing you want to do is you want to label your terms. So we have an x squared here, 12x squared. We have an 8x squared right here. And then we also have 9x over here, a 9x over here, and then we also have a -21. Let me change the color very quickly. -21 right here, and a -20 over here. So we're going to have 12x squared plus 8x squared plus 9x plus 9x minus 21 minus 20 plus 4x cubed. So this is going to give us 20x squared plus 18x minus 41 plus 4x cubed. Now be careful. You want it from highest to lowest. The highest power to the lowest power. So we have a 3, we have an x cubed term, we have an x squared, an x, and then we have an x to the 0, or negative 41x to the 0, right? So we're going to have, from the highest, it's going to be 4x cubed plus 20x squared plus 20x, or plus 18x, excuse me, minus 41. Okay. Oh, plus 20. Oops. So this is going to be actually, hold on. Minus 21 plus 20. Okay, I got it. So it'll be 20x squared plus 18x oh my, I wrote this one really I wrote this one like completely wrong. Oh my goodness. Hold on. So let me write it down again. Let me just write this one down again. Let's just look at this one again. Oh my goodness. Sorry about that, guys. 12x squared plus 9x minus 21 plus 4x cubed plus 8x squared minus 5x plus 20. So, let me just make sure this time. 12x squared, 9x, negative 21, 4x cubed, 8x squared, negative 5x, and 20. Okay, so we're going to have 12x squared. So one of the things that I do recommend is always look at the one with the highest power first. Here we have 4x cubed, okay? So I'm going to write that down. That way, it can be in order of descending exponents. What I mean by that, it can go from 3 to 2 to 1, da 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 da. So always, every single time you have a polynomial, you always go from x cubed, x squared, x, and then x to the n minus 1, da 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 da. Right? That's how you write a polynomial. So we have 4x cubed, and then we also have 12x squared plus 8x squared, so it's going to be plus, and then 12 plus 8, that's just 20x squared. We also have, so as we go along, we're going to cross them out. We also have 9x and negative 5x, so 9x right here, negative 5x over here. Okay. Plus 20, my bad. So then we have plus 4x, and then negative 21, so obviously oops. So this one and this one is basically this one. And then we already said about 4x cubed. So right? And then 20x squared, that's where we got 12x squared plus 8x squared, right? And then negative 21 plus 20, that's just going to be minus 1, right? So you have 4x cubed plus 20x squared plus 4x minus 1. Right? Now subtracting is a little different. We're going to have 7x to the 4th minus x squared plus 6x plus 1 minus 5x cubed minus 2x squared plus 3x plus 2. So this is where you actually distribute your negatives. So you have 7x to the 4th minus x squared plus 6x plus 1 minus 5x cubed plus 2x squared minus 3x minus 2. So this is going to be 7x to the 4th, and again, you're going to label your other terms. So we have an x squared, a negative 2x squared, we have a 6x and a negative 3x, and then we also have, hold on, a negative 1, or a positive 1, and a negative 2 here. And then we also have, hold on. So, hold on, guys. I'm gonna do, so we also have negative 5x cubed right here. So then you bring them together, 7x to the 4th minus x squared plus 2x squared plus 6x minus 3x plus 1 minus 2. So let's go ahead and re-highlight it. Negative x squared and 2x squared, that was this part. And then 6x and negative 3x, that was, oops, oh my goodness. My bad. Oh my goodness. I did not want to do that. So 6x and negative 3x, that's the other part, and then 1 and negative 2, that's the other part. Okay. Right? So then we just bring it together, 7x to the 4th plus x squared plus 3x, and then 1 minus 2, that's just negative 1. Okay. Oh, and minus 5x cubed, my bad. Oops. Minus 5x cubed. This one, so it's going to be 7x to the 4th, and, wrong pen, minus 5x cubed plus x squared plus 3x minus 1. Okay. So you see, that's how you do it. Multiplying polynomials using distributive property. Okay. We have 2x plus 1, so multiplying polynomials. So we have 2x plus 1 times 3x squared minus x plus 4, right? So this is going to be 6x cubed. So really, it's going to be the following. 2x times 3x squared plus 2x, 2x times negative x plus 2x times 4, and then plus 1 times 3x squared plus 1 times negative x plus 1 times 4. You're doing this FOIL method, right? So it's going to be 6x cubed minus 2x squared plus 8x plus 3x squared minus x plus 4. So we have 6x cubed, and then we also have a negative 2x squared and a 3x squared. That's going to be, so negative 2 plus 3, that's 1, and then x squared, so it's plus x squared, and then plus 8x minus x, that's just plus 7x, and then plus 4, right? So then we have 6x cubed plus x squared plus 7x minus 4, or plus 4, excuse me. You can also do it using a table. So notice here that you have 2x times 3x, that's, or 2x times 3x squared, that's 6x cubed. 2x times negative x, that's a negative 2x squared. 2x times 4, that's 8x. 1 times 3x squared is 3x squared. 1 times negative x, that's negative x. And 1 times 4, that's positive 4, right? So this is just what they're trying to say here, ax plus b times cx plus d. This is what, I believe I went over this at the very beginning of algebra, or when I was looking at this video, or when I was looking at this book, rather. I've gone over this for sure. So this is what it would be, right? And FOIL method, it's first, outer, inner, last. That's what FOIL method is, and you add the products, combine like terms, etc., right? Now, a perfect square trinomial, that is when two binomials are squared, or when a binomial is squared, that's when it's multiplied, and you just go ahead and say x plus a quantity squared is x plus a times x plus a. You do FOIL method and you get x squared plus ax plus ax plus a squared. That's x squared plus 2ax plus a squared. That's what a perfect square trinomial is, right? Now, let's say we want to expand 4x minus 1 squared, right? So it's going to be 4x minus 1 times 4x minus 1. Let's say we want to do it using a box method, right? Box method, right? So 4x times 4x, that's 16x squared. So really, let me just explain what this means. Okay. Let me just color code here. So let me draw a box. And let's do something like this. Hold on. Okay, well, so let's just do it like this. Okay, so 4x, let's just do 4x like this. Let's do 4x, and then plus 1. So let's kind of do plus 1. And then let's do here 4x plus 1. Or let me do it in this color. Or sorry, minus 1. Oh my goodness. Minus 1. Minus 1. So here we're gonna have okay. I'm trying to think. I don't know why. Okay. Hold on, guys. I don't know why. So, okay. X squared. So let's pretend that this is a plus, and then let's pretend that this is actually a negative 1. So really we can rewrite this as 4x plus negative 1 times 4x plus negative 1. And if we make u equal to 4x and v equal to negative 1, we can say that u plus v times u plus v is really just u squared plus uv plus uv plus v squared. So we have u squared plus 2uv plus v squared, right? But then we have, so it's going to be 4x squared plus 2 times 4x times negative 1, and then plus negative 1 squared. Now, That's the same thing if we were to say u minus v. So, honestly, let's just do it this way. 4x minus 1 times 4x minus 1, so it's going to be u equals 4x, v equals 1. U minus v times u minus v. That's going to be u squared minus uv plus v squared. So it's going to be u squared minus 2uv plus v squared. So really we're going to have 4x squared minus 2 times 4x times 1 plus 1 squared. So we're going to have 16x squared minus 8x plus 1. So really this is going to be 16x squared. This is going to be 4x. My bad. This is supposed to be... Oh my goodness. It's supposed to be negative 4x. And then this is supposed to be... So... this one's supposed to be negative 4x, and this is supposed to be 1. Oh my. Hold on, guys. Oh, crap. Okay. Oh my, sorry about that, guys. Oh, I don't know what just happened. Okay, so then we have 16x squared minus 8x plus 1. That would be our answer, right? So really, I mean, this is how they did it over here. This is what I was trying to do. Now in box method, I mean, you can do it in box method as well. Now, binomials, so the difference of squares pattern is a plus b times a minus b equals a squared minus b squared, right? So like this one, 9x plus 4 times 9x minus 4 is really just 9x quantity squared, right? Minus 4 times 9x. So it's really going to be minus the quantity 4 squared. So really it's going to be, not 18, oh my goodness, 81x squared minus 16. Right? Okay, so let's do x plus 4. So, for example, x plus 4, let's do this one, times 3x plus, or minus 2y, excuse me, plus 5, right? So here we have 3x squared minus 2xy plus 5x, and then 2xy plus 5x plus 12x minus 8y plus 20, right? Because you do x times 3x minus x times negative 2y, or sorry, plus x times negative 2y plus 5 times x, and then plus 4 times 3x plus 4 times negative 2y plus 4 times 5. So then it would be 3x squared minus 2xy plus 5x plus 12x minus 8y plus 20. So then you combine like terms, you have 3x squared minus 2xy plus 17x minus 8y plus 20. Okay. Gosh. All right. So now we're going to get into factoring a trinomial, right? Which, I won't lie, it's not my favorite. It's really not my favorite one because sometimes it's a little hard to explain. So let's just try to do, so let's do x squared minus 7x plus 6. Let's factor this, right? Now, the way that you would do it is if they taught you Xbox method, we know that a is equal to x squared. So basically, we know that this is of the form ax squared plus bx plus c. And here, a times c goes here, and b goes on the bottom. So we have a times c, that's 1 times 6, 6. And b is the middle term of your trinomial. So what is the middle term? It's going to be negative 7, right? Now, what are two numbers? So two numbers. So like m times n equals 6, and m plus n equals, what is it called? Negative 7, right? I want to see if something works very quickly, guys. Give me a second. mn equals 6. Hold on, everybody. I really want to know if this works. I don't think it will. Never mind. I was trying to do something, but I don't think it works. Or actually, hold on. Maybe it will. So, okay, hold on. M over 1 plus 6 over m equals negative 7 over 1. M squared plus 6 over equals negative 7. Oh boy. Okay. Okay, never mind. Never mind. I don't want to do that. I don't want to do that. So, okay, so the best way I can explain this, you want two numbers that multiply to 6 and add to negative 7. The best way to do this is to, I don't know why. So the best way to do this, and honestly, like, the So the best way to do this one is to say, to list the factors of 6. We have 1 and 6, so that's because it's 1 times 6, -1 and -6. We have -3 and -2, and then we also have 3 and 2. Now, what are two numbers that multiply to 6 and add to -7? If you look at this, it's going to be -6 times -1 is equal to 6, and -6 plus -1 equals -7. So what you're going to do, so that satisfies those two. That means that m equals -6 and n equals -1. Now you want to go ahead and draw your box, right? Or actually, well, if a is less than 1, or if a equals 1, then that means that these two you can just say those two things. So you can say x plus n times x plus m. So basically the way that what I'm trying to say here is that we can just go ahead and say that this is equal to x minus 6 times x minus 1. Or if you want, you can do box method, but you really don't have to, because I mean, honestly, if a is less than 1, you just go ahead and do this. So like basically that's why over here when I did box method, you can just do this. You don't have to do the box. Now factoring by grouping is another thing. So I've never done factoring by grouping. Hold on. So like, so let me see, hold on, let me see, 5x squared plus 7x minus 6. This can be 5x squared plus 3x plus 4x minus 6. I'm going to try to do it this way. Hold on. X times... Or you can say 5x squared plus 6x plus x minus 6. So this can be x times 5x plus 6. Okay, hold on. Plus x minus 6. So let me just keep going. So basically we can say 5x squared plus 2x plus 5x minus 6. This can be x times 5x plus 2 plus 5x minus 6. Or we can also say 5x squared plus 6x. So did we already say 6x plus x? Oh yeah, we did. So then we can say, this is a little bit harder. Doing it this way is a little bit harder, I feel like. You can do a table. You can say, so you can do this, hold on. Factors of, let me do it this way, hold on. So factors of negative 30, because it's negative 5 times 6, right? And then over and then not over, the other side is going to be addition of both factors. So you would have, so it would be 5 times negative 6, negative 6 times 5, negative 15 times 2, negative 10 times 3, negative 3 times 10. And then the addition of these two would be negative 1. Negative 6 plus 5 is also negative 1. Or actually, I can do... So the addition of negative 5 plus 6 is positive 1. Negative 15 plus 2 is negative 13. Negative 10 plus 3 is negative 7. Negative 3 plus 10 is 3. So which one of these matches up with 7? Well, we can also do... Oh, wait, hold on. So, the one that matches up is, this one here, okay? So it's negative 3 times 10. Now we can say, so basically, let me see how they did it here. So then that means we can go ahead and do it this way, ax squared so p equals a negative 3 and q equals 10. And then we have, we know ax squared, so we have 5x squared, right? We have negative 3x minus 3x plus 10x, and then plus c, which is negative 6. So this can be x times 5x minus 3 plus or really it can be this is a very interesting way. I've never done it like this before. So really, this is 5x times x plus 2 minus 3 times x plus 2. So then you do 5x minus 3 times x plus 2. You can also use the fundamental theorem of algebra to do this one. I mean, to be honest, that's literally how you solve any polynomial. That is if, like, you have it in terms of more than one. So really, let's just do this one again, but this time I'm gonna do it using fundamental theorem of algebra. So 5x squared, was it minus 7x? Plus 7x minus 6, my bad. Sorry guys, hold on. So the fundamental theorem of algebra, even though I haven't gone over this yet in this section, but I will soon. Basically, it says that So if we do, what is it called? So if we have it of the form ax, so right? So the factors of the constant, if you look at the constant, you can do the factors of -6. So you have -1 and 6, -2 and 3, and that's it, right? And then the leading coefficient, you can just do 1 and 5, right? So, that means that we're going to have plus or minus 1, plus or minus 5, over plus or minus 1, plus or minus 6, plus or minus 2, and plus or minus 3. So that means that the factors can be 1 over 1, -1 over 1, 5 over 1. So the possible factors, 1 over 1, -1 over 1, 5 over 1, what else? I'm trying to think. Oh, it would be 6 over 1, or no, not 6 over 1, my bad. So really it would be, I don't think it would be anything, well, actually, I'm wrong, hold on. So that's how you would do it if, if you were doing this using fundamental theorem of algebra. Now, you can use the quadratic formula to do this one, but again, in reality, I mean, I would just learn the Xbox method. So that's the easiest. I was gonna try to do it without Xbox, but it's really hard. We have A, and then we have B, and then we also have C right here. So the top part is going to be A times C. Oops, my bad. A times, oh my god, times, and then we have C right here. So that'll be -30. And then 7. So two numbers that multiply to -30. So let me do the products of -30. So going -1 and 30, -2 and 15, -3 and 7, and sorry, -3 and 10. So that means that A times C equals -30, and A plus C, or mn, really, mn equals -30, m plus n equals 7. So what are two numbers that multiply to -30 and add to 7? Well, look at this. -3 times 10 is -30, and -3 plus 10 is 7, right? You always want to list your factors. That's the first thing, and that'll tell you. You would ask yourself, what two numbers multiply to get the top part, A times C, which is the first term times the last term, and what two numbers add to get the bottom part. right? So, let's see here. It'd be -3 and 7, right? So then we go ahead and do the x box, or not the x box, the box method, right? Here goes your leading coefficient, or your leading term. So the leading term is 5x squared, right? Here goes your mx, and then nx, and then c. Now, it can happen that m and n are mixed up, in which you wouldn't be able to find the proper numbers, but you would just have to switch them. So basically, you would have -3x, 7x, and your c value, which is -6. So then you would do, so basically you have 5x and x, and then 7 and x. If I do, so let's say I try to do x and 5x, right? What number divided by 5 or times 5x would give me 7x? I don't want fractions, right? I want whole numbers. So that's why I put 5x over here instead, and an x right here. So 7 times x would be 7x. But then again over here it gives me -3x. So what does that mean? I'm probably going to just have to switch my numbers. 7x, -3x, right? So it's going to be x, or 5x and x. Wait a minute, hold on. 5x squared plus 7x minus 6. Oh, -3 and 10. My bad. Ugh. It'd be like this. So it'd be 5x times 2, and then -3, or, so 5x times x, 5x times 2, -3 times x, and then -3 times 2. So it'd be x plus 2 times 5x minus 3. We're going to do another one of these, because I feel like I took a little too long to explain that. So let's factor 2x squared plus 9x plus 9, right? So if we do x box method, we want to do this one times this one, so 2 times 9. And then we're going to put the 9 here, so right here. Now, we know that 2 times 9, that's 18. A times C, right? And then B is right here. So that means that I want m n to be 18 and m plus n to be 9. Now how do I find that? I'm just going to list the factors of 18. 1 times 18, 2 times 9, 3 times 6. So then I say, okay, so 3 times 6 is 18, and 3 plus 6 is 9, right? You see how they match? So then I say, okay, this is going to be 3x, this is going to be 6x. So then I draw my box. And then I say the left part, that's going to be 2x squared. That's ax squared, the leading term. Then I do my first part, which is 3x. The second part, which is 6x. And then the positive 9 on the right side. So I'm going to have x times 2x. And then I have 3 times 2x. And then x times 3, and then 3 times 3. So my factors are going to be x plus 3 times 2x plus 3. Okay. let's move on. Now the difference of two cubes pattern. So a sum of two cubes and a difference of two cubes, okay? There's a difference. It's funny. Okay, so usually, so I'm gonna do one example, right? I'm gonna do one for sum and I'm gonna do one for difference. So this is one that I always forget. So when we have x cubed plus y cubed, that's x, it's gonna be hold on. So it's going to be x plus y times x squared minus xy plus y squared. Now x cubed minus y cubed, that's going to be x minus y, I think, times x squared plus xy plus y squared, okay? So basically, let's say I have, I don't know, x cubed plus 8, right? That's going to give me x quantity cubed plus 2 cubed. So that's going to be x minus 2 times x squared plus x times 2 plus 2 squared. It's going to be x minus 2 times x squared plus 2x plus 8. Or plus 4, excuse me. So I really suggest that you guys memorize these. Otherwise, at least try to memorize one of them and then play around with it and then make sure you kind of get it to do this one or to match this one. So that way you can do it that way, and you can do FOIL method and stuff if you're really good at that. That's how I would do it. These two are very they're very similar. That's why they're a little bit hard to memorize. Okay. Let's move on. So if I go, I'm gonna go to, what section is this actually? Hold on. Rational expressions. Let me do some of these. Okay. Wow. Oh my goodness. Okay, so I'm gonna just do literally like maybe two of these. I'm gonna do one that's multiplication and I'm gonna do one that's division. Or I'm gonna do one, so let me first do one where you have to just simplify the top and bottom. So 12n squared minus 29n minus 8, so over 28 x squared minus 5x minus 3. So let's factor the top. So we have 12 times negative 8. That's going to be negative 96. And then negative 29 over here. Now two numbers that add to negative 29. So I'm going to do the factors of negative 96. So I have 1 and negative 96. And then I have 2 and, let me see, hold on. 96 divided by 2. That's negative 48. And then I have negative 3 and 32. So look at this. Or I can also say 32 and, or negative 32 and 3, right? So negative 32 plus 3 equals negative 29, and negative 32 times 3 is negative 96. So I can use those two numbers. Now go ahead and do your box. So then you have ax squared on the top. So the top, because we're trying to factor 12x squared minus 29x minus 8, right? So the leading coefficient is 12x squared, and then we also have negative 32x, 3x, and negative 8. So then I have 3x and 4x, or I can say, I can actually say 4x and 3x, so that way it matches. So I have 1 times 3x is 3x, 4x times negative 8 is negative 32x, and then 1 times negative 8 is negative 8. So the top, if I rewrite this, 12x squared minus 29x minus 8 over 28x squared minus 5x minus 3 is equal to, so I can say that this is equal to 3x minus 8. The top is equal to 3x minus 8 times 4x plus 1. And I can factor the bottom. I can do the exact same thing I did for the top. So I can say that the bottom, so we have 28 times negative 3, and then on the bottom we're going to have a negative 5. So let me just write this down very quick for those of you who don't understand what I'm doing. I'm gonna draw like a little cheat sheet to remember, or to help everybody. Whenever I have ax squared plus bx plus c and I'm trying to factor, I always have this. So I have the x box, and the top is a times c, the bottom is b, and then I have two numbers m and n that help me with a times c and b, right? So basically, this is also m times n, and this is m plus n, right? Do not confuse a and m and c and n, because they're not the same thing, okay? So this one is I feel like this topic is probably the most difficult for me to explain. So basically we have something like this, mx, nx, and c, right? That's how I'm doing it every single time. Now you can practice over and over until you get it with, with different, what is it called? With different questions. It's really a pattern, that's what it is. So we have 28 times 3, that's 84, negative 84. And then you have negative 5, so then we're going to list the factors of negative 84. So you have negative 1 and 84, negative 2 and 20, or no, hold on. Negative 2 and 42. Negative 3 and 28. Negative 4 and 21. Negative 6 and 14. Right? And then we also have this one is weird. Hold on. Okay. Huh. Okay. Hold on. Give me a second, guys. I'm doing it. So then we have negative 7 and 12. Okay, so then these are the two numbers that, or rather it's going to be negative, or 12 and negative 7, really. Or not 12 and negative 7, negative 12 and 7. So we're going to have negative 12 and 7 right here. So because that means that negative 12 plus 7 equals b, and negative 12 times 7 equals a times c, right? Actually, disregard this second part. Do not. Basically, what I'm trying to say is that negative 12 times 7 is also equal to a times c, but it's really mn equals ac. But don't overthink. Do not even worry about that, because I really don't want to confuse you guys. My point is that negative 12 times 7 is negative 84, but also negative 12 plus 7 is negative 5, and those are the two numbers that multiply to get negative 84 and add to get negative 5. That's the whole point here. So then you draw your box, right? And you put your leading coefficients of 28x squared, and then you do negative 12x, 7x, and then you do your c value, which is negative 3. So then you have 4x and 7x, and then you have 1 and 7x. Then you have 4x and negative 3, and then you have 1 and negative 3, right? So it's 7x minus 3 times 4x plus 1. So then you have so then these two cancel out, so then you have 3x minus 8 over 7x plus 3, or minus 3, excuse me. It's a lot of factoring, okay? It's a lot of factoring with these. It's a lot of factoring. That's why you have to kind of keep practicing to make sure you understand it. Now, as far as these go, let's do one that is not that difficult. So let's just say we have, t squared minus 4 over I'm trying to see, hold on. T squared, like this. So what is this going to be? The more you look at it, the more you remember that this is really just t minus 2 times t plus 2. You can also do Xbox method. You can say that 1 times negative 4 is negative 4. And then the middle term is just 0 because there's no, like, in terms of t to the first power. So then two numbers that multiply to negative 4 and add to 0 are negative 2 and 2. So then that gives you t. So basically you do your box method, right? it's going to be t, so it's going to be t squared, negative 2t, and negative 4. So then it's going to be t times t, 2 times t, and then t times negative 2, and 2 times negative 2, which is negative 4. So this is going to be t plus 2 times t minus 2. Now you do the bottom. 1 times 6 is 6, and then the middle term is just 5. So you have t squared, and then two numbers that add to 6, or multiply to 6 and add to 5 are 3 and 2. So then you do 3t, 2t, and 6. So then you have t times t, 2 times t, t times 3, and 2 times 3 is 6, right? So this simplifies to t plus 2 times t plus 3. So what does this simplify to overall? This simplifies to t minus 2 over t plus 3. Okay. Let's move on. So find the x and y intercept of each. So this is chapter 2, right? So, okay. Let me just do a few examples of these. So, if we have, for example, number 5, we have y equals negative 3x plus 6. Find the x and y intercepts. So, remember the x-intercept is where y equals 0. So basically here, if we do 0 is equal to negative 3x plus 6, negative 6 equals negative 3x. So if we divide by negative 3 on both sides, we get x equals 2. So the x-intercept occurs at x equals 2. And in coordinate form, it's going to be 2, 0. So what does that mean for the graph? Right? If we, so hopefully, let me see if I can find any graphing paper on here. I really don't know. I really don't think they have any more graphing paper, or I don't know if they have graphing paper on here, but, I'm trying to see if maybe they do, but I really don't know. I doubt it. Okay, never mind, they don't. They don't. Okay. I don't know what happened. Hold on. I don't know what happened. Hold on. Okay, I guess, oh boy. Give me a second, guys. I don't know what happened. I think... I'm trying to see exactly what happened, because I really don't know. My screen is, like, not... I'm just gonna turn off the stream very quick, and I'll be back. I'm trying to figure out what happened here. I'll be back, guys. Give me 1 second.